everyone, and thank you for joining us today for our Rigging with Lever Tools Safety webinar. My name is Gisela Clark, and I'm the Social Media Specialist at Columbus McKinnon Corporation, and will be your host for today's webinar. Today's webinar is part 3 of a 3-part rigging series. Columbus McKinnon lever tools can be used as a hoist and used in the leg of a sling as a compensator. Today you will learn how to do a pre-operational inspection and the considerations and preparations needed to use these tools safely. Thank you for your participation today. Presenting this morning will be Peter Cook, our training manager, specializing in rigging and load securement. Peter has dedicated 15 years to Columbus McKinnon as an engineer, designing lifts, slings, and forgings. He's traveled throughout the world teaching proper rigging techniques, rigging gear inspection, and hoist and crane inspection and maintenance. A few quick points before we get started. We'll be recording the session today, and the recording link will be provided on our website as well as being emailed to each of you in attendance. Everyone has been muted, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes of questions at the end, and for those that we don't get to, we will be contacting you within 24 hours after the webinar with our answers. So we really appreciate your attention, and now I'd like to turn the meeting over to Peter so we can begin.
Hi, welcome, and thank you for attending the webinar today. Today's topics that we're going to go through is identifying the safety standards that apply to lever hoist, how a lever hoist works, conducting pre-operational inspections, and rigging with lever hoist properly. And like Gisela said, we'll take some questions at the end. So some of the safety regulations that we adhere to at Columbus McKinnon is the main one is ASME B30.21. A lot of people ask, well, what's the OSHA standard for that? And really, there is not an OSHA standard that covers it. So OSHA only has a general duty clause that they can use, and they'll probably piggyback on ASME to try to enforce some of that if it's a pretty good violation. Other than that, we adhere to ASME B30.21 as far as our safety standards. Real quick, just the anatomy of a lever tool. We'll take a look at it externally here. You see that the hook, that's covered under ASME B30.10. The body itself, things of that are covered under ASME B30.21. And again, the lower hook, it's a hook, so it's covered B30.10. And the hook standard is separate from the 21 standard. You actually have to have 2 standards to look at if you want to adhere to all the safety standards for that.
Excuse me, Peter,
yeah.
You've got a lot of background interference. Could you try switching over to your computer audio?
Okay. 1 second here.
There's an option on the right-hand side of your screen under audio where you can select computer audio. I apologize, everyone. We want to make sure this is a good experience, and there was just a lot of interference.
Is that better, Gisela?
Much better.
Okay, we'll continue on.
And go ahead and hang up your phone, since everything will be via audio on your computer.
Sounds good. Sorry about that, everybody. Okay, so what are lever tools used for? Simply for stretching, pulling, tightening, positioning, and in hoisting applications. Okay, and we'll be going over every part of it and how it's used, and then have a pretty good application example and using it in as the leg of a chain sling and how to do that as well. So that's pretty interesting. How does a lever tool work? Well, believe it or not, a lever tool is not much different than a chain pawl. We do have just ratcheting type lever tools, which do not have a brake; they just have a ratchet and pawl. But the others that we do sell have what's called a Weston type braking system. So really the only difference between what we call chain pawls and lever tools is a hand wheel and the lever, how you operate that unit. So here you can see there's what it is the hand wheel, the back of it, or the back of the tool will have a hub, and that compresses friction discs along a ratchet and to a bottom hub, and which creates one solid gear, which allows us to have a secondary holding with the ratchet and pawl. Okay, so here's an actual picture of it, and this one's taken from the CM Polar, and you can see when I take that handle off, that's pretty much what it looks like under the handle, where you see the friction hub with cam there. That's what it looks like under the handle. And what that does is it kind of just compresses everything, and you're allowed to make lift. And then in the lowering direction, what you're doing is creating a gap, and it's controlling the descent of the load, but it's self-locking. So the minute you stop operating it, it kind of locks up on itself. And the best way we can describe how that works is similar to a jar. So if you were to put what I always like to do in my classes is show like one of those ball canning jars, and you have those little discs in there in that jar top, and as you turn it, it just gets tighter, and eventually the jar turns in your hand. Well, that's the lift wheel. The lift wheel will turn in your hand, and it locks itself up. And that's really pretty much how the hoist works. And in the lowering, again, the lowering direction, we're just loosening that cap, and then we're creating such a fine gap between those friction discs, so the load is coming down at a controlled descent, and immediately stops as soon as we stop operating the unit. So that's how the mechanism inside our manual hoist lever tools work, and they're pretty much the same units. There really isn't much difference in how they operate. When before we operate any tool or hoist, we want to do a quick inspection. We don't want to use anything that is going to be dangerous to use. So this in general is a pre-operational check. Some of these things apply on there, some of them don't, but we want to go look at it from top to bottom. Does it operate properly? Does it break? Are the brakes working? We can lift light loads, things of that nature. Checking out the hooks. The latch must be there, must be present, unless it constitutes a hazard for some reason. But for the most part, you're going to need the latch. The latch must be on there and operational. Going through the chain, we'll talk about chain inspection and wire rope. Is it reeved properly? Is the chain going in where it's supposed to be going in, and the welds look where they're supposed to be, and things of that nature? Our manual hoists don't have limit switches, so that don't apply. Oil leakage, usually these are grease housings, but we want to look at to see if there's any cracks, anything unusual sounds, warning labels all in place. And then just general housekeeping, where we're operating in, we want to make sure the space is clear, that there's no trip hazards or anything that's going to distract us from the job that we're going to be doing. So the required markings, so the first thing, if you don't know how much the tool can lift, you shouldn't use it, right? So there should be an identifiable rated load on there. It could be on the lower block or the lower hook. It could be on the hoist body itself. So you want to take a look at it, make sure it's there. The identification, the manufacturers, who made it, the serial number, model number should all be on there. And the warning labels are usually on the handle, and that needs to be on there as well to be compliant. All right, everybody understands about, I've probably heard the McDonald's incident where someone spilled hot coffee and got sued. Well, same thing. You got to have warnings to say, hey, don't lift people, don't do this. I call it the 10 Commandments of lifting, and it's usually what we have on all our hoists, and that needs to be maintained and stayed on there. Okay, if it's not marked properly, it should not be placed back in service or not used. And there's what I'm talking about, just the different things, the serial numbers, the markings, the capacity markings could be on the hook block, the lower hook block, or on the hoist itself, and then the warning label on the handle. Okay. Hook inspection. People like to do some crazy, especially with lever tools. They're just because of anchorage points and things of that nature, just do some crazy things with it and end up pulling hooks out. So it's a really good idea. Take a look at those hooks. If you see, especially the top hook on lever tools tend to bend over a lot, just from wrong application of it or just not applying it right. And I'll show some examples of that in this slide of how to do that properly. And then some crazy people like to weld to our hooks or use them in a high heat environment. Again, these are alloy hooks, and if you do weld to them or get any heat damage, it's going to mess them up, and we don't want you to use them after that fact. So that, in many of these cases, there should have been a sling or something in between, or a specialty tool made to attach to, and not used in that manner. Check out the hook. Make sure it swivels. It can rotate freely. Again, the latch must be there and present and operational unless it constitutes a hazard. If we look for any deformation, anything causing us concern, if it looks kind of distorted, and I have some slight examples in there, some extreme, some slight. It could be bent slightly. We don't want to use it. The throat opening, any distortion causing an increase of throat opening of 5% and not to exceed a 1/4 inch. Probably on the lever tools and the smaller lever tools, you're going to see the 5% over the 1/4 inch. The 1/4 inch we see on the larger type hoist applications. or what's recommended by the manufacturer. The manufacturer always has final say on their product, so, but that's a general rule of thumb. And wear not to exceed 10%, okay, in any area of the body of the hook itself. We don't want to see anywhere more than 10%. And then a load pins, you probably won't be popping out load pins for operational use. However, if you do want to take a look at that, or you can see some visible wear, if you're seeing visible wear on the pin, it is probably 10%, but that's what the wear criteria on any pins go. But the operator should be looking at as many things as possible before they go and operate that unit. Take a look at the chain quickly. This doesn't take long. Usually there's 5 foot to 10 foot of chain on lever tools, so this does not take long at all. You want to do a link-by-link inspection, rotating the chain, looking for nicks, gouges, bent, heat damage, twisted, stretch, corrosion, and any type of chemical damage. Again, when in doubt, take it out. That's my philosophy. So if it's causing any concerns, it's not worth using. And here's some good pictures of bent, twisted links, stretched links, interlink wear, heat damage, things that can go wrong. And in general, a chain on lever tools should not be used for rigging purposes, and what I mean is should not be used to wrap around loads or attach loads. You should always have some sort of attachment. The chain should always remain in a straight line within the lever tool.
Peter, I have a question for you. What type of chain is used in our CM hoist?
Well, on our manual hoist, CM uses what's known as disc grade chain. It's proprietary to CM. It has a pitch that allows it to fit in our lift wheels. It's through hardened. It has a dot on there that represents disc grade. Some of our import units, it's called a DIN grade 80, which has a sideways T, or depending on how you look on the chain, or a T on there. Not to be confused with grade 80 rigging chains. It's not the same stuff. Rigging chains have the ability to stretch 20%, take a lot of abuse, where any type of lever tool or hoisting chains, they're not meant for rigging. They're meant to have dimensional stability so that they go over lift wheels, and so we don't want to rig with them. And they can't stretch very much either. The manual hoist, about maybe 7% stretch. All right, so keep in mind it is a different chain. And then just real quickly, our electric hoist use what's known as star grade, and it's a much harder chain, a case hardened chain, and again, not to be used for rigging. But very good question, Gisela. Thank you for that. It's just not ordinary chain. It is a specially chain, and you should stick with the manufacturer's chain that they recommend for that unit because it's made specifically for those hoists.
Okay. Thank you.
Thank you for the question. Lever hoists can also have wire rope. We have some wire rope hoists that we use. And the rejection criteria, if you see 12 randomly distributed wires in one rope lay or 4 broken wires in one strand, and you can see what I'm talking about there off to the right is what a rope lay is. It's basically a rope lay is a complete revolution of a strand and the horizontal distance that that measures. Okay, and you can see there the strand, so whatever that complete revolution is, that's a rope lay, and that's your rejection criteria for that as an operator. Wear 1/3 of the original rope dimensions. Near end fittings or terminations of the wire rope where you have the compressed fittings. We don't want to see any broken wires near there. That's probably it's failing at that point. And then no bends, kinks, crushing, burn caging, corrosion, heat damage. And then look at the shivs, look for wear and corrugation because you can definitely jump shivs or create more damage to the wire rope, so which would put the operator in danger. We have strapping hoists, primarily used in the utility industry. Obviously, they want non-conductive material, and you can see that guy there. He has a special handle. It's a non-conductive handle, but they use that for utility lines. It's another application. You can see what we call the pork chops or the wire rope grips, which we also make pulling those lines. But really, for strap hoists, and even in general for hoists for straps for rigging, it's an all or nothing thing. You cannot have any type of damage whatsoever. So wear, frame, cuts, nicks, UV degradation, that's a big one, especially if used outdoors. It really damages the strapping. Heat damage, no distortion of the structure, no knots, excessive grease, oil, or grit. So if it's really caked on there, it's probably breaking down. Sorry about I advanced that slide. Foreign materials impregnated, and then broken stitching. So again, if you're when in doubt, take it out. And then here's some very good examples of damage and some extreme, but again, you can get the idea. We have cuts, even this where it says cuts, small little cuts like that. You know, that wasn't intended to be there, and definitely that's a much weaker tool. And where it would break, we have no idea. So all that you see there will be cause for removal from service. And then the outer, inspecting the body itself. Anytime you see a bent handle, that's a good sign an overload has taken place. So you can see in this hoist here, the handle is bent, the latch is sprung out, the hook has been pulled. That it needs to immediately go out of service and not use. The chain looks fairly stretched, so that was severely overloaded. Lever tools, you got to be careful that you're in the direct line of fire when using these. You don't really have a lot of room to get out of the way of tension. So you really got to be careful what you're doing. And these tools, I can tell you right now, are probably abused a lot. They just, people tend to overload them, even though we instruct them not to. They just do. We can equip them with load limiters, some of our tools, to prevent that, but still, people will still do it. Safety end stops. Be sure those are on there, right? That the last thing we want to do is run the chain out of that hoist. We had an incident in Skydome one time. It's the Toronto Blue Jays stadium when they were doing there, and there was a fatality because that worker was missing the end stop, didn't measure out what he was doing as far as tensioning was concerned or moving a plate into position for welding, and pulled the chain right out of the unit. And if you had that end stop in there and had a brief 5-minute quick overview of safety on the usage of that tool or attended this webinar, that person would be alive today. So everything that's on these units, it's important that it's working properly. You're working on a tremendous amount of weight. These things can do a tremendous amount of weight, even though they're small. What we recommend for an operational test, and not to be confused, this is not a load test. This is an operational test to be sure that the brake is working properly. You want to do at least 100 pounds times the number of load supporting parts of chain. So that means that, a single part is 100 pounds. If I have 2 parts, 200 pounds, and so on and so forth. So there's a picture coming up where I'll point it out, but it shows multiple readings. I think it's 4-part reading. It would actually be a 400-pound operational test to check the functionality of that equipment.
Okay, we're going to step in quick and do a quick poll.
Sure.
So if everyone could go and answer this question, what is the rejection criteria for a hook opening per ASME B30.10? Is it a 1/4 inch or 10%? A 1/4 inch, a 1/4 inch or 5%? 1/8 of an inch or 2%? Or none of the above? We'll give you about 30 seconds here to vote. Looks like it's between A and B. We've got about, come on, we need a few more of you to vote, and then we'll wrap this up. Looks like 30% think A, around 70% think B. Someone's thinking none of the above. Let's see. What do you guys think? Another couple seconds? Okay, it looks like the overwhelming majority thinks that it is B. And Peter, go ahead and tell them what the right answer is.
1/4 inch or 5% is correct, or what's recommended by the manufacturer. That is what's in the B30.21 standard. And so, yep, so they were paying attention. Very good, nice job.
Excellent. Okay, can everyone see the screen again now? Should be good to go. Okay, go ahead.
Okay.
Peter, you can continue.
Very good. So let's talk about rigging with lever tools, or the usage of them. And so the main thing we want to know before we do is the constraints of each tool. And every tool or every hoist has what's called the amount of pull force to lift the load, okay? And it's all different. So I just took our 3/4 ton units and compared them. And you can see there at the bottom, it says the CM653, only 33 pounds of pull force, all right? And then you get up to the CM pullers, 640 pullers, 58 pounds of pull force. And I didn't put it on here, but the rigging tool, which is just a ratchet and pawl type lever tool, almost takes 100 pounds of pull force to do that, okay? Now, anyone on this call is more than capable of doing 33 pounds of pull force. Anyone on this call is capable of doing 100 pounds of pull force. We designed these tools for one-person operation. So with that being said, if I were to put 100 pounds of pull force, and I can do it easily, that 653 tool, I can overload at 3 times and not knowing it, right? So in general, you got to really understand what the pull forces feel like. So whatever manufacturer by they show them in their catalogs, and you want your operators trained on what that feels like when you're at capacity and not to pull any harder on it. If somebody is using a cheater bar, a snipe, asking for an extra hand, 2 people to do it, they're putting themselves in grave danger by doing that. So not a lot of people realize that. And that goes for chain falls as well. They have the same type of pulling force. So you got to be aware of that. You know, the low pulling force tools are excellent because they're easy to use. However, you know, there's got to be some training there. Hey, don't pull it too hard because you're going to overload. And again, we can supply load limiting devices if that's a big concern. There are as an option. And so you can see in this picture, this crew here is doing it wrong, and they sent me some pictures. They got some violations issued to them, and I got sent these pictures, and they wanted to know what they did wrong. And whoops, I'm sorry. And basically, I got that is a 6-ton puller, and you got 2 guys operating it because they said, well, the one guy gets tired doing it. Well, he just wasn't strong enough because he was overloading. And so now they're standing right there, and they're severely overloading the tool. Not a good situation. And again, there's a 4-part read for you there, and that would be, if you can see that, let me just highlight it real quick. If I can get the highlighter working here. Yeah, not working, but where you can see, you can count the chains there, 4-part reeving, and that would be a 400-pound operational test. So that's a pretty big tool. That's a pretty big animal for a lever tool right there. And we're going to the next slide here. Whoops, sorry about that. Here's where applying it wrong, where the anchorage point is incorrect. So there, what will happen is you'll either pull the top hook or both. You'll damage them. This is in fabrication. This is what we call pulling things together, tensioning them together for fabrication, squaring them up. That's used quite often. For that application, but there's not a proper anchorage, and that's what happens to the hooks when everything's said and done. So there would be the correct thing. They're what's called pulling clamps. And they're not welder's clamps, they're pulling clamps. They actually have a rated load on there, and they're not meant for lifting either. But they're like a vise, and what happens, it gives you 2 nice eyes where then you can attach your unit to it and do the same job without damaging your unit. But you want to have a means of attaching the lever tool and not tip loading these or putting them on a fabrication where it's going to damage something. Okay. The next one here, again, another tensioning application, and this is in a shipbuilding industry where they're drawing a plate close and they're going to weld it. There's welders on the other side of that vertical plate, and they're meshing it up. And you can see here they're tip loading the lever hoist, and the anchorage point, which is a vertical plate lifting clamp, is letting go. So you can see slack in that lever tool. That plate could let go. That plate could fall on the welders on the other side of it. And I took that picture personally in one of the places I was at. Again, a very dangerous situation.
Peter, aren't they used? Aren't those clamps used to grab and lift plates? I mean, what would make it slip like that?
Well, yeah, the way the clamps work is, you know, almost like if those finger handcuffs, if you ever had those when you were a kid and you pull, the harder you pull, the more grip it has. Well, in this case, when there's no weight on there, they're really not gripping. And so once that plate got tensioned in a position and the clamp wants to let go, there's no more tension on it. There's vibrations going on from the welding and jostling it around, and so there is no grip anymore on that clamp. And depending on the condition of the clamp, it could let go. So again, we want to go with the pulling clamps on there. We want to put those on there instead, where it acts like a vise. Much safer to do that. So it may be that you bring the plates in with a vertical clamp and put them into place, but quickly you want to have another setup before you get the weight off, is to get these pulling clamps on there and put the lever tool into position to hold everything in place. That would be the safe application. So again, a lot of people will just continue to use the clamp in that position and attach to it, and you need a second step to that setup.
Okay, thank you.
You're welcome, and great question, because that's a common error. This clamp, this tool here, you can see that here's a case where the lever tool is being used for rigging. and the chain there is actually supporting an I-beam. They're using the lever tool to tension an I-beam to the ceiling so that they can install a trolley into a confined space. And what it's doing is damaging the tool. We're really not operating that tool properly, and the operator is now standing under a suspended load. So, and there's nowhere for that gentleman to go, and just wrong all the way around. So, not a good use. In this case, we would you need to get jacks and things of that in and get the proper equipment. It's not an application for a hoist. You know, you need jacking equipment to get in there. But again, common misuses. And now here's another application. Now, why I wanted to put this in the seminar here is because there was I tend to go on LinkedIn a lot and monitor some things, and there's been a lot of discussion over the past few months about can either a lever tool or a manual hoist be used as a compensator or a leg of a chain sling. Is that possible to do that, and are they? I do got to say, you know, check with your manufacturer to make sure that, yes, that's the way they want that tool to be used. But the answer to that question is yes, especially with, you can use it. We would recommend the ones with the Weston type brake, the braking system, all right? And this is more of advanced rigging, but it's a quite common practice in general industry and in construction. And as long as you know some certain things, it's a safe lift. So obviously, when we do this, we want to know where the center of gravity is located before lifting, okay? Know your weight, obviously. Know the share of load of attachment points. Know your sling angles or stress multiplier, and know your tension, because things are going to be changing as you're leveling off the load. Well, how do we accomplish this? And that's what I'm going to show you in a minute. So we have let's just say this structure here, hypothetically, is 6,000 pounds. So we want to know the location, that we know where the center of gravity is. Maybe it's something we've always lifted, or maybe we did make that lift and then we set it back like, hey, did we do this right? And maybe that's not the way to do it, but let's face it, people do it that way. They lift it, get it level off, but they really don't know if it's done that. We don't recommend doing that. There should be a plan in place, and that's what we teach you in our rigging training courses, how to find center of gravities and share of loads before you do the lift. In this case, between the attachment points is 15 foot, right? We have from one end on side A is 10 foot to the center of gravity. That little symbol there is the center of gravity. And from side B is 5 foot. So my loading is different, right? I have different, the weight is not distributed evenly. It's not a symmetrical load. So basically we want to figure out how much percentage of the weight is on one side versus the other side. And we can do that very easily. We take the span, which is 10 foot plus 5 foot is 15 foot. And the percentage basically is your 10 foot divided by your overall span 10 foot, which is 67%. All right, so that tells me on side B, where the center of gravity is closest to side B, that 60% of that 6,000 pounds is towards that end. So that side B is seeing, so I take 0.67 times 6,000, that side B is seeing 4,020 pounds on that side. Okay, now I know my share of load on side B. I subtract that from the 6,000 pounds, and on side A is 1,980 pounds. So that's my weight distribution. So life is grand. So if I did a 2-point pick in this case, I would know exactly the hoist and the chains to spec out. In this case, we're not doing a 2. We're doing a single-point pick and basically making a sling. So now we need to figure out how much tension are we putting in those chains. Do we have the right equipment for the lever tool and then the chains? So now that we know our share of load, let's take a look at that.
Hey, Peter, a quick question came in.
Yeah.
Whoops, I just lost it now. The question that came in was, why not recommend a deck chain for that application?
Like the decking chain. It is. We do make an alloy chain called stack chain for theatrical. Decking chain is not in general. Decking chain is not an alloy chain, but we do make theatrical chain to do that. I suppose you could do that. You know, that's another application for what we call stack chain, and that's similar to our Herculoy grade 80 chain that we use. And so if you're going to do that, that's what I would do with that.
Okay, great. Thank you.
Type of chain, and not just standard decking chain. A lot of people like to use the lever tool because it's or a chain fall in this application because it's quick and easy. The adjustments are easy to do. and they're readily available on hand. A lot of people, there's tools on site and chain falls on site to do this, so it's quite common practice. But very good question, I agree. So we got to size up our angles, and side A, looks to be a 45-degree angle. Side B looks to be a 60-degree angle, and there's what's called load tension factors. In this case, a 60-degree has a load tension factor of 1.155, a 45-degree 1.414, and a 30-degree is a load tension factor of 2. We don't recommend going below 2. Now, these can be found on rigging charts, and in classes we teach you how to calculate that stuff as well and how to figure out those numbers. So we just referred to rigging charts for these numbers. So if we said side sling A is at a 45-degree angle, then we take our share of load, which is 1,980 pounds, times it by our tension factor. And so that lever hoist and chain that's rigged inside A is seeing 2,800 pounds of tension. Now we can go and size the equipment properly based on that. On side B, the same exact thing. We just take our 4,020 pounds, and in this case, it's a 60-degree. If you're kind of hemming and hawing that, well, is it 60? Is it a little below 60? Is it more towards? Use the one, instead of 60, use 45. Be conservative. Excuse me. So this case, we're using 60, and this, so we times that by 4,020, and we get 4,643 pounds of tension. And I'm sorry, the answer there is wrong in the PowerPoint. I didn't catch that. The answer for side B is 4,643 pounds of tension on side B. So you can see there the tensions are all laid out. So this is basically what's called a rigging plan. We're doing a plan. And we should do this before we rig. Consider, are we using a choke hitch there? Our D to D ratios, these are things that we need to consider also to reduce the values of our chains if we're using chain slings. And so that's in general. I know I went through this stuff pretty quick. I went through a variety of applications, and I went through those calculations pretty quick. But that just shows you all the different applications of lever tools, a real brief overview of them, how to inspect it, how to use it properly, the anchorage points, and using it as a hoist or as a compensator. Again, I just want to quickly review. Make sure your operators know the pull, what the application is, how much pull they should be using on it. Get the feel for it. In some applications, you might want a more robust tool. A typical import design. We do sell import designs as well from our own factories as an open design to it. But if you're in a really rough environment, you might want to consider like the puller, which is enclosed. So there's different. We have all. You wonder why do we sell all these different tools? Because they are designed for specific applications and work better in specific applications. We have markets for that. So contact us, and we'll point you in the right direction of what tool you should have for the job. Incidentally, if you want to learn more about more training, this is a brief snippet of our rigging training that you saw. But here's some of the trainings we have coming up. Excuse me. We have a hoist repair. If you want to learn how to repair these tools, lever tools, chain falls, electric hoist, July 16th to the 18th in Columbus, Ohio, and on Ohio State University. We also do Little Mule utility hoist repair. That same. This is going to be a different week, July 24th. August 5th to the 9th is the rigging course and crane operator, train the trainer. And if you don't want to do train the trainer, you can just take the rigging course that week as well. And we will go through inspection, basic rigging, and advanced, and show you all the calculations. And then we're doing live loads and lifting live loads and moving them around. It's a great workshop if you want to learn how to rig. August 12th is another what we call another hoist repair certification, but incorporates the wire rope hoist. And this one's a little bit longer, but all the large wire rope hoists done at our training facility in Tonawanda, New York, which we call our Niagara Training Center. And then we're also at a couple trade shows. ITI is having a trade show in Edmonton, Alberta, June 17th to the 19th. And then we're in Houston for the API show, July 16th through the 17th.
Okay, Peter, we've had a bunch of questions come in. I'll take them one at a time, and we'll give about 5 to 8 minutes for more if you have more. The first one is, I'm going to read this, it's kind of long. In my field experience, after double checking with a dynamometer, whenever you have to use more than one hand to operate a chain fall or lever hoist, it's being overloaded. Most lever hoists have different length handles to allow for proper operating leverage. Is this a good operating practice?
Yeah, hope I answered this question right. The engineers design various length handles. Each handle is a different length. The handle length is designed to get that pull force. So when we design a lever tool, we design it with the handle length in mind and how much pull force it has. We do design, believe it or not, we do design if everything goes correctly, and this is just a safety mechanism, but it's not foolproof by any means, and not a means to, it may not happen, but it should. To handle the brake, so that you don't do it anymore. If you're overloading, we design the handle to break off. And so you're like, well, why would you do that? Well, it's better than getting somebody killed and having this chain or hook snap. So the handles are designed at some point to break. Hopefully that never happens, but a lot of people will call and say, hey, this cheap handle on there, and I've actually seen people weld on a solid bar and say, well, I just need something more solid. Well, they were severely overloaded. But yes, it is. If done correctly, and if you go by the rigging plan steps, and you know your tensions, and you know your tool's in good shape, and you know how to inspect it and how it works, it is absolutely safe practice.
Okay. Next question is, the chain used on lever hoists and chain falls is different than the chain used on electric hoists. Is that correct?
That is correct.
What is the actual nomenclature of the said chain for each?
Well, yeah, right. We use what's called, it's through hardened chain, okay, and CM uses it's just called disc grade chain. That's our chain that CM is making for a number of years. It's a through hardened chain for manual hoists. Imports have what's called a DIN grade 80. It has a strength level of a grade 80 chain, but again, it's not to be confused with grade 80 rigging chains. It's not the same. And on our electric hoists, it's called star grade. Everybody wants to know, well, what's the grade, what's the material made? It's a formulated chain, it's special alloys, things of that nature, and proprietary to CM. But the star grade is a case hardened chain. It is extremely hard and has a tough skin on it because it moves fast speeds through a lift wheel, and that chain needs to be pulled up. Think of rub your hands together when they're dry as fast and as hard as you can, and you can't do that for long because it gets too hot. So think of an electric hoist at the speeds it goes through. You got steel on steel going over a lift wheel, and the amount of heat that must generate, and you have to lubricate it. However, that's got to hold up, and that's why that star grade chain is made that way. It's got to hold up. It's got to be able to take that amount of pressure and that amount of heat. And the disc grade, it doesn't have to be quite that level because it's slow speeds, it's manual operated. But nonetheless, you do have pressure and heat build up because you have steel on steel, and it has to hold up.
Okay, we've got one more question we're going to take before we wrap up today. Are schematics available for your hoists? Are user service rebuilds a recommended practice?
Matter of fact, all of our maintenance catalogs have schematics of the hoist in the back of the maintenance catalogs, and I believe you can find them all online on our website, which is cmworks.com. And so you can go to our library, and we should have just about every manual for our hoist on there. And if you don't see the manual that you need, give us a call, and we will get you what you need. We'll get you any schematic that you need.
Okay, there's one more point that came up, which, Peter, I'd like you to read over while I run this next polling question, and then we can address it. So we have one more polling question for you. I'm going to go ahead and launch.
Okay, so I can't see the questions?
Let's see. All right, really quick. Before this webinar, were you aware that lever hoists can be used in these types of rigging applications? Answer yes or no. Okay, let's see what we're getting. 50-50, exactly even. We got a few more people to vote. Excellent. Okay, Peter, let's see, we'll give it another minute. Almost everyone. Peter, I shot it over to you via email.
All right, give me a second here, and I will...
Great. Okay, well, it looks like 50-50, Peter. So we raised some awareness today, which is really good. Thank you so much for voting. We appreciate that feedback. Okay, Peter, we're going to go back to your presentation. Peter, if you can just turn to the last page, and while he looks over the last comments, just go to the last page with all of our social media. I just want to direct a few more resources to you before we wrap up today. If you are not subscribed to our blog, you can subscribe via email. We post about one blog article a week on all kinds of things in various industries, from application photos to customer questions and answers to industry news, all kinds of things. If you're on Twitter, you can find us at CMCO Live for our more industry news, and CM Entertainment for our focus on the entertainment industry. We're also on Facebook. You can find us under Columbus McKinnon Corporation. We have a YouTube channel where this recording will be placed later this afternoon, and we'll send you a link to that. We're on LinkedIn. You can follow company updates there under Columbus McKinnon. And we also have a Google Plus page in case you're there and would like to follow us. So those are all ways that you can connect. We're very active on social media and love to share news and information. So please consider connecting with us there. And now I'll go back to Peter.
Yes, someone's asking about the tension factors, and the rigging charts will show tension factors for every 5 degrees, and this gentleman is correct who said that. And just for this presentation purpose, I just pulled out some standard angles. But yeah, there is a way and I mentioned this, we can calculate those tension factors right in the field. In this case, he said measure 36 inches up your chain and then straight down, kind of like a plumb line, and you get your height. So sling divided by height gets you your tension factors. Yeah, you can go 24 inches, you can go 12 inches up, and then drop your plumbing straight down. It's a right angle triangle, so it doesn't matter how far, but it's a number. I always teach a number easy to remember. 3 feet is easy to remember. That's a great suggestion. 24 inches, whatever number is easy to remember. You measure up and then drop straight down. You can come up with your tension factors. We do like to teach this stuff in our training courses and show you how to do it from top to bottom. And when we show charts, we show you where all the numbers are coming from and how they're obtained and how you can do it in the field and check yourself. Absolutely. What I show is very conservative. I said if you think it's not quite 60, go to 45. That's very conservative. Or if it's not quite 45, go to 30. That's, again, very conservative. But if you really want to fine-tune it and know exactly the tensions that you're getting, this gentleman's suggestion is the way you do it. And of course, yep, we would teach that to you.
All right, well, we are wrapping up right now. We just want to thank everyone again for your participation today. And like I said, you'll be receiving an email within the next 24 hours with a link to our recording on our YouTube channel. So feel free to share it and with your colleagues. And again, we appreciate your time. Thank you very much.